So, in the last class what we studied about the TCP, how it establishes a connection and how the port to port communication is that takes place by the port numbers, the different types of port numbers, ephemeral, well known port number and all those. And the data unit that is used in the TCP protocol is the, as we discussed, is a segment, right. So, because it is a segment, it comes from the stream data service that is generated by the application layer of the sender, and these streams of data are again chunked into separated into several chunks, and each chunk is again added with the header information, and combining this data with header, we say that is a segment in case of the transport layer or in the TCP protocol suite. So, what is the header of this, the format of the segment? As you have studied the format for the IP and for the frame, so this will be a segment format, you can say. So, this segment format has got, as usual, two fields. One is the data field that comes from the upper layer or the application layer, you can say, and there is another field, the header field, and this header is like your IP. Again, the size of the header is from 20 to 60 bytes, similar to your IP header. Minimum should be 20 and maximum it can be 60 bytes. So, what are the different fields in the header format of this TCP? We will see. So, we have a set of 4 byte words, that is the 32 bit words. Minimum should be 5. So, we will see the minimum words and then we can have the optional or the extra word. The first word that it has of the 32 bit is 16 bit, two fields having 16 bits each. One is the source port address and another is the destination port address. One is the source port address and another is the destination port address. The next field is it's absolutely 32 bit field, or the whole word is used for a single purpose, that is the sequence number. We will see what this sequence number and what is why this sequence number is useful in TCP later. So, now it is a 4 byte word or a 32 bit length word, which is a sequence number. The next field is the acknowledgement field. Again it is a 32 bit field. So, this is acknowledgement number, and then we have a field which contains some control fields. Divide this into two major parts. One is a 16 bit length, which is in window size, which decides the window size, and the rest 16 bit is again divided into some sections, like one is a HLAN section. You almost know what is the HLAN section and all. This is a 4 bit length HLAN section. Then there is 6 bits are reserved 6 bits, and then you have some control fields, and they are very important. We will study them one by one later on. First one is an URG field, that is urgent field. Then you have an acknowledgement field, that is ACK field. Then you have an push field, that is PSH field. Then you have an RST field, that is reset field. Then you have a sync field, that is synchronization field, and there is a finish field, that is terminating field. So, you have few control signals: urgent, acknowledgement, push, reset, sync and finish. So, these are the every individual field has got its own significance. We will study them later. Then we have another word again, which is divided into two fields. One is the checksum, that is always present in every field. It is a 2 byte field, checksum, and then you have another field which is again 16 bit or 2 byte field, which says it is an Argent pointer. We will see why this Argent pointer is required. Argent pointer. This is what is the minimum required fields for your header of the segment, and then you have the options field, which we are not going to study now. This is optional again. The other fields are optional that we are not going to study now. So, now coming to the first field, the source port address. Because this is a TCP communication, we know that the communication is between the port to port communication. Earlier, if you remember, the communication was between the host to host. So, the address, basic address used was the IP address, destination IP, source IP. But now when it comes to the port to port communication, the source port and the destination port has to be mentioned here. So, these two fields, source port address and the destination port address, says either the sender is in server or in a client, depending on the kind of ephemeral port number or well known port number. Depending on that, these two port numbers will be decided, source and the port number, I mean the destination port number. We have already studied about all those, so we are not going to study details about these two. But this port number, source port number, is from the sender who is generating the segment, and the destination is the receiver who is receiving the segment. So, this sender could be a client or it could be also a server, and the same is true for the receiver. It can be a receiver or it can be a server for the, I mean it can be a server client or it can be a server for the other one, right, and depending on that your port numbers are decided. So, that will be taken care of by the OS. So, we do not bother for that. We know that only the source port and the destination port of 16 bit each, meaning how much will be the port number size, you know that 64 KB you can say, right. That many number of numbers can be generated, 16 K. Then the next one is your sequence number. Why this field is so important? We understand that TCP supports stream data service. Stream data service means, as we discussed in the last class, every byte will have its own number. Every byte will be numbered to identify. So, usually byte numbers are used because it is a stream data service. So, let us say 1000 bytes of data are generated and this is divided into 100 segments, then each segment will have 10 bytes, right. So, the first segment will have 10 bytes, the second one will be again starting from 11 to 20. That means every byte will have their own numbers. And when these 10 bytes are accommodated or encapsulated into one segment, what is the first sequence number or first byte number? That is what is mentioned in the sequence number. The initial byte number of the segment is mentioned in the sequence number field, right. So, how this sequence number is generated and how they are decided? Let us say a sender generates a segment, I mean a data. This is the sender, a bunch of data has been generated. So, when the data is generated, an initial sequence number is generated randomly. An initial sequence number is generated randomly. So, let us say in my case the sequence number I generated is 1. It could be 5000, it could be 900, 9000, any number. So, that sequence number initially whatever has been generated is the first sequence number or the initial sequence number of the first segment to be transmitted, right. So, now let us say in our case 1000 bytes are generated and the random ISN, the initial sequence number, is equal to 1. That will be generated by the OS randomly. So, we do not have to bother for that. And then another thing will be decided, the size of the segment. The size of the segment has to be decided. So, these two data are there. Now, you chop the data into smaller sections or the segments. So, what will happen? The first sequence number, what will be the first sequence number of the first segment? The first segment will be 1. And what will be the sequence number of the second segment? The initial sequence number plus the size of the segment, which is equal to 11, right. And the sequence number of the third will be the earlier one 11 plus the size again, which is equal to 21. That means every segment having the first byte address who decides what was the sequence number of the previous segment and what was the size of the previous segment. calculating these two values, the current sequence number will be generated, and that is given in the field of sequence number, this one. This enhances the reliability of connectivity, or it ensures that every data byte that has been streamed from the sender side has been received by the receiver and has been pushed up to the receiver application program. That is why your TCP is much more reliable in comparison to any other protocol in any other layer even, right. So, this is what is your sequence number field. Coming to the next field, the acknowledgement number. You know why the acknowledgement is required? To ensure the arrival of the packet at the receiver. That is what is the requirement of an acknowledgement. Now, let us say earlier we are using the acknowledgement in DLL, if you remember. What we are sending at that time? The frames. We are sending the frames at that time, and every frame was almost numbered starting from 1 to n, right. So, when frame 1 was sent to the receiver, what the receiver was sending? It was sending acknowledgement 2, indicating the next frame expected by the receiver. And once the sender receiving the acknowledgement 2, it understands that my previous frame has been arrived safe. So, now I should send the frame 2. That is what was the objective of using the acknowledgement, and the principle remains same for the TCP, I mean the TCP protocol also. But instead of frames, now we are changing the segments, or you can say the bytes even. The bytes, because usually the transmission is over bytes. So, let us say the sender sends 50th byte, and so in that case what is expected is the 51st byte is expected. So, your acknowledgement will carry acknowledgement for the 51 or the 51st byte number. So, definitely the next byte will be transmitted. If you have a single segment and that is being transmitted. If you have multiple segments, it remains the same, because one segment will be transmitted, and once that is done, the next segment will be carried out. But again, there are certain cases when the segment has to be again streamed out. Like in a segment, it may happen that there are some bytes which are very urgent. We will see them later. So, those bytes has to be transmitted first. That means again the segment is considered as a stream of bytes. So, which byte will be sent first and which will be sent later will be decided depending on the Argent pointer and all. So, that will be again, if you are using a stream data service, every byte will be numbered and your acknowledgement will decide which byte will be sent first or which segment will be sent next. So, it decides the number of the segment or number of the byte to be sent by the sender next. And because it is again 32 bit, again the 32 bit, so it says that how many segments you can use or how many acknowledgement numbers you can use, 2 to the power 32. That many number of bytes can be handled by the TCP. That is what is your acknowledgement number. Then coming to the next field, you have the H-lane field. This field already we have discussed in our IP. What it says? The number of 4 byte words present, right. So, because its minimum is 20 and maximum is 60, definitely the value will be minimum 5, maximum will be 15, right. If no options are used, only the H-lane will carry 0101. If all 60 bytes are used, then it will carry 1111. In between, any number could be possible. That decides what is the size of the header, and accordingly the data size will be decided. That is what is your H-lane field. Then there is another field, you have the reserve field. We are not going to discuss about that. Then you have the set of fields, that is the urgent field, the acknowledgement field and the post field. Let us say we will study about this. The urgent field, the acknowledgement field and the post field. Every field has got its own specification or significance. We will study the different functions or different services of TCP will decide what kind of control pointer or these values will be set. When this value is set to 1, you have a field urgent pointer, if you have noticed this one. there is a field called Argent Pointer. So, this Argent Pointer field will be valid only when the Argent Pointer is set to 1. Meaning, this will say in a segment, let us say initial 5 bytes are urgent, 1, 2, 3, 4, 5. These 5 bytes are urgent within inside a segment, and rest of the bytes are not that urgent. So, in that case, you want that these bytes to be processed fast in comparison to the others, right. So, what will happen? The Argent Pointer field in the the header field will say what is the number of the last urgent byte. That means, in this case the last byte is number 5. That means, up to 5 is the urgent bytes to be processed at any cost, to be processed immediately, right. And to make this valid, your Argent Pointer will be set to 1. So, what will happen when the header goes to the next layer and the processor sees that the urgent bit is set to 1, it immediately goes to the Argent Pointer field, finds what is the last byte, the whole of the urgent bytes, and those bytes will be processed accordingly. If this remains 0, then this will be not considered at all, though you put some value in the Argent Pointer will have no meaning, because you did not set the Argent Pointer set to 1. So, the whole of the segment will be considered as a regular segment, so without any specific attention on that. Then another is the acknowledgement field. If this field is set to 1, that means this acknowledgement field what you studied here, the acknowledgement number is valid. If this is not set to 1, if the acknowledgement field is not set to 1, this field totally does not have any sense, right. Then the other field, the push, the reset, the synchronization and the finish, this will study slowly when we will go for the some of the other operations and the services of TCP in future. Then next is the window size. The rest of the fields we will study later, just keep them on hold for a time. Then you have the field, the window size. This already we know while we studied about the DLL, right. What the window size says? It indicates the capability of the receiver, and the objective remains same in TCP also. The window size says how many bytes can be processed by the receiver. So, if I say I have a buffer, remember this TCP uses buffer, in the last class I said, because it supports the stream data service. So, it has a sending buffer, it has a receiving buffer. So, that buffer will decide what will be the window size. If I have a buffer of 200 bytes, then I can fix up a window size of 100 or 150 or 50, any in between. So, depending on this window size, your number of bytes transmitted from the sender and the receiver will be decided. So, window size indicates or instructs the sender to send that many number of bytes without waiting for the acknowledgement, right, and that is the capability of the receiver at any point of time. So, this window size is decided for that. This is what is your window size, as we discussed in the flow control of DLL, the same remains same, here also it is same. Then you have the field checksum, the checksum field always present for deciding the or the calculating the detecting the error in any segment, that is what is your checksum. And Argent Pointer, as I told you, we will see the Argent Pointer case in the later cases when you need an urgent. When the error control section will come, how the Argent Pointers are decided or how the retransmission takes place, we will see study more about this Argent Pointers and that. And options is the field, we do not bother now, because we are not going to study about the urgent fields, the options fields of the TCP. So, this is what is your TCP header or the frame format, the format of your segment. Now, we will see how the flow control is maintained. As we studied in the last class, one of the major or a very prominent service provided by the TCP is the flow control. When you know that the flow control is done by the DLL, data link layer, we know that DLL does some kind of flow control. So, why TCP again does the same? If that layer is providing us the flow control, if the flow is maintained in the DLL, I mean the lower layer, what is the requirement that again you maintain the same in the upper layer? We did not study about the flow control in IP layer, right? That was not I mean mandatory, it was immaterial for us. Now, but coming to this TCP, it is a must. Why flow control is required in TCP? UDP does not support flow control, so we are not bothering for that. But in case of TCP, can you tell me why this flow control is required? What it will synchronize? What it will synchronize?
Because Argent streams the bytes, that means it has a higher responsibility of link.
The main objective is, you say TCP supports stream data service. When you say stream data service, meaning streaming has to be in sequence and streaming should not lose a single byte of data. If it loses the data, that means you are losing the reliability. And as you are coming to the upper layer, that is the TCP, there are no more layer who will take care of the responsibility of this flow control and all, because after that is your final receiver, your application layer. So, this is the last layer of your the whole model who has to ensure that your communication is reliable, because next to that the TCP sends the actual data to the upper layer or the process, you can say. So, before delivering the actual data, it has to ensure that all the flow control and error control has been maintained, right. Your DLL does the same thing, we agree, but what DLL does? It looks for the frames. Within the frames, what is a frame again? Frame is raw data, right. So, that has to be again framed into, or that has to be sorted into the number of bytes. The bytes has to be delivered byte by byte or streamed service. So, in that case, you cannot depend on the service provided by the DLL, because above DLL you had an unreliable service, that is IP. So, in case of any miss or miss out in the DLL, or in case of any flaw that was detected in the DLL, could be rectified by the TCP, because below TCP you had a very unreliable protocol which is IP and connectionless. So, to have that reliability, again the TCP provides all the services that was provided by the DLL, and now it is in the, again you can say in the micro level. So, total reliability from the error control and the flow control is done by your TCP. So, coming to that, again we know that you have a provision of sliding window. Earlier case we had a sliding window, but that sliding window used for frames, number of frames, data encapsulated into frames, and those frames were transmitted in sequence. But the data inside the frames, again they were checked or they were streamed out in the TCP by the sliding window feature, right. So, again the feature or the principle remains same for your sliding window. As we studied, there is a buffer here, there is a buffer in the receiver section, and these buffer sizes are decided as per the number of bytes, how many bytes the buffer can hold, and your window size is decided to be less than your buffer size, your window size to be less than the buffer size. And now this window what we studied in the DLL has to follow the same principle in the TCP layer as well, but the only difference is that instead of the frame numbers, either you are using the segment numbers or you are using the byte numbers, right. So, every segment, when you, let us say I send a segment 1. When I send the segment 1, I send along with the segment, I send the sequence number, I send the size of the bytes or the number of bytes, you can say, it's number of bytes. That means the segment that is carrying the data also carrying the number of bytes along with it in the right sequence, and they will be stored in the buffer. two options. You can have again the stop and wait, that is also possible. Send one segment, wait for the receiver to send the acknowledgement, I mean hold the sender and can do that, but that is again tedious and time consuming, you are wasting the network resources. Other one, you do not use any acknowledgement, go on sending the segments, the receiver will process, that is again a waste because your data will be lost and total communication is waste. So, the best option is send in window size, you have least waiting time for the sender and you have the reliability achieved because your every segment is acknowledged. That is what is your window size, a sliding window, and as we have studied, your window expands in this direction, I mean sorry, it shrinks in this direction and when it expands in this direction. So, if this is the window, as it goes on sending the data, your number of segments are reduced and as it receives the acknowledgement, your expansion goes in this direction, right. So, how this sequence is being done, this is different than, slightly different than what we studied in the frame sliding window for the DLL, because it has a separate feature called the window management, how it manages the window, it is a more trivial than the one we studied, how this window management is being done. And there is another feature that is called the silly window syndrome. So, what is this syndrome and how this syndrome could be avoided? Who creates the syndrome? The sender, the receiver or the channel, and how these syndromes could be eliminated. That is what is all about your flow control, and we will study them in the next class.